This next problem says arctan of negative square root of 3, which means inverse tangent of negative square root of 3. So it's asking where is tangent negative square root of 3. So I look at my unit circle, and inverse tangent is only on the right side. I'm not looking at the left side of the circle at all. It's like it's not even there. And I want a tangent with a negative square root of 3. It's right there at 5 pi over 3. But remember, this isn't called 5 pi over 3. This is called positive pi over 3. So this down here is negative pi over 3. So my answer is negative pi over 3. Okay, number 8, inverse cosine of negative 1. So where is cosine negative 1? That's what it's asking. Come here to my unit circle. Inverse cosine is only the top. So I'm ignoring the bottom of the unit circle, and I'm looking for a cosine that's an x-coordinate of negative 1, and it's right here at pi. So my answer is pi. All right, now here they're saying find the inverse and then find the sine. Now a lot of times we think, well, wouldn't they just cancel each other? Sometimes they do, sometimes they don't. So we need to look at the unit circle then. So that we always work from the inside out. So the first question is, where is sine 1/2? So I'm answering this first. Where is sine 1/2? So I go to my unit circle. Remember, I'm only on the right side of the unit circle for inverse sine. And I want it to be, was it positive or negative? It was positive 1/2. That's the y coordinate of 1/2. And it's right there at pi over 6. So I'm taking the sine of pi over 6, which then when I go to here and I go to pi over 6, the sine is 1/2, and I'm back to a half. So this was one of those instances where, yes, sine and inverse sine, in a sense, canceled one another out. But again, I want to emphasize that's not always going to happen. Let's go to number 10. Number 10 says, first take, because you always work from the inside out, take the cosine of 5 pi over 4. So I go to my unit circle, cosine 5 pi over 4 is here. Cosine is the x, so it's negative square root of 2 over 2. So this answer is negative square root of 2 over 2. This says arc cosine, which means inverse cosine. So now I have to ask myself, where is cosine negative square root of 2 over 2? Go to my unit circle. Since it's an inverse, I'm only looking at the top of my unit circle, and I want the cosine to be negative square root of 2 over 2, which is right here, and that answers 3 pi over 4. So I get 3 pi over 4. Notice I didn't get 5 pi over 4. I can't get 5 pi over 4 because 5 pi over 4 isn't part of my restricted domain. It's not in the 0 to pi part of my unit circle. Let's go to the next one, number 11. First, find the tangent, because you work from the inside out, find the tangent of pi over 6. So go to my unit circle and look for pi over 6, and my tangent is square root of 3 over 3. So inverse tangent of square root of 3 over 3, which is asking me, where is the tangent square root of 3 over 3? So come here. Inverse tangent is only on the right of the circle. Square root of 3 over 3 is right here, so the answer is pi over 6. All right, let's do my next one. Start on the inside, sine of 270. 270 is here. The sign is -1. Now I need to ask myself, where is sine -1? So I go to my unit circle. Since it's an inverse, I'm only looking at this part of the unit circle for sine. That's it. And sine is the y coordinate right down here. Sine is -1. But I don't call this 3 pi over 2. Remember, this is positive pi over 2, which makes this negative pi over 2. So the answer here is negative pi over 2. The next couple ask you to do it using a calculator. All right, so we're going to do our calculator. It says nearest hundredth of a degree. So make sure your calculator is in degrees. Mine is not. Let me put it in degrees. And then I just type in inverse cosine. Oops, forgot to type in the rest of it. Inverse cosine of 0.65. And I get 49, hundredth is 2 decimal places, 0.46 degrees. Okay. Here, when it says arctan, that just means inverse tangent. Arcsine just means inverse sine. And so you're just typing these into the calculator. So I'm going to let you do these remaining 4 on your own. I mean, the remaining 3, so that those 4 are done. All right. Now we come to 17 and 18. It says solve where x is between 0 and pi over 2, which means 0 to pi over 2 says that all of my answers are in quadrant 1. They don't want any answers outside of quadrant 1. So let's see, got to solve for this. Got to get x by itself, so I'm going to divide both sides by 6. Sine of x equals 1/2, because 3/6 is 1/2. Take the inverse. And I get inverse sine of 1/2. So where is sine 1/2 is what it's asking. In quadrant 1. So I go to quadrant 1. Sine is the y coordinate right here at the half at pi over 6. So the answer is pi over 6. This means quadrant 1. All right, let's solve this one. Well, on this one, I can't divide by 2 because that's in with the tangent. So I'm going to just start off by taking the inverse so that I can get rid of that word tangent. Well, here tangent and inverse tangent cancel. I'm just left with 2x equals, where is the tangent 1? That's what this right here says. Where is tangent 1? In quadrant 1, remember. So I come here to quadrant 1, and I look for a tangent of 1 right there at pi over 4. Now to finish solving for x, I divide by 2, and I get x equals pi over 8. go to our next question. A radar tracking station is located 2 miles from a rocket launch pad. So let's see. Here is the radar. I'll just call this right here. The radar tracking station is located here. Then I have 2 miles down the road, I have a rocket launch pad. Okay, that's 2 miles. Express the angle of elevation. So angle of elevation would be this angle right here. This is where theta would be. Of the rocket from the tracking station as a function of the altitude of the rocket A. Altitude means height. So this must be A right here. And so we were asked to write it as a function of it, which means we're not going to be able to solve. So I do need to look at this. Let me see. This would be my hypotenuse. And I have the angle. I have 2 miles in the A. Is this a sine, which is opposite over adjacent, a cosine, adjacent over hypotenuse, or tangent, opposite over adjacent relationship? This is opposite and adjacent, so this is a tangent relationship. So the tangent of theta equals A over 2. So if I was to try and solve for theta, I would take the inverse tangent of both sides. And I get that theta equals the inverse tangent of A divided by 2. So it says, if the altitude, that's capital A, is 1.2, what is the angle of elevation? Well, here's my formula. So theta equals inverse tangent of 1.2 over 2. So I go to my calculator. Inverse tangent of 1.2 divided by 2. We do need to end the parentheses to show that I'm taking the inverse tangent of this, not the inverse tangent of 1.2, and then dividing that answer by 2. So make sure you end that parenthesis. And I get, does it say what to round to? It doesn't. 30.96, I guess I'll say.